Okay, so the first problem that we're looking at for the review is finding the end behavior and the number of turning points for our polynomial. So looking at this polynomial, obviously we have some work to do before we can figure out what the end behavior and turning points are. We have to start by putting it in standard form. So we're actually adding two polynomials here, which means that we just basically combine like terms. So I have a 3x squared and an x squared. So I'm going to combine those. 3x squared plus x squared gives us 4x squared. I have a minus 2x and a positive 5x. So when I combine those, I get a positive 3x. Then I have a 4 and a negative 2. So combining those, I get a positive 2. So this is going to be the equation I'm actually looking at when I'm talking about end behavior and the number of turning points. So the end behavior was given to us in a chart. So remember to review that chart. Make sure you memorize it for tomorrow. We find the end behavior by looking at the first term. Our first term is 4x squared. So we need to look at two different things here. We need to look at the degree and we look at the coefficient. If the degree is 2, that means that it's an even degree. If we have an even degree, that tells us something about our graph. It means that we either have up, up, or down, down. It tells us that the end behavior is going to be the same in both directions. So we'll have something that either looks like this or possibly like this. They're going in the same direction. That's what the even degree tells us. When we have an odd degree, that means we're going in opposite directions. So also the coefficient is going to tell us something about our graph as well. So we know it's either up, up, or down, down. We just don't know which. The coefficient tells us which one it is. It's a positive 4. When we have a positive, that means it is up and up. When we have a negative, it's down and down. So the end behavior for this one is going to be up and up. To find the number of turning points, I look at the degree. There was a formula for this. The number of turning points is n minus 1. So n in this case is 2, meaning I have one turning point. Okay, so we are finding the degree given a table. So we are going to start by branching out. Remember, we do this using subtraction. So 36 minus 12 gives us 24. 12 minus 2 gives us 10. 2 minus 0 is 2. 0 minus 0 is 0. And we continue on. Right, and so we can tell we do not have a degree 1 here because we didn't end up with the same number. So we're going to continue, branching out again. 24 minus 10 is 14. 10 minus 2 is 8. 2 minus 0 is 2. We're going to continue on with this. Okay, and we can tell here we do not have a degree 2 because we still don't have the same number. So we're going to continue on again. 14 minus 8. I'll let you guys go ahead and take a minute, fill this out. Okay, so we finally ended up with the same number, which means that we have not a degree 1, not a degree 2, but a degree 3 polynomial. So our degree for this is 3. All right, for this one, right, we're writing the factored form of the equation. So to write the factored form of the equation, we start by finding what our zeros are. So we have 1, 2, 3 zeros. But like we said in class, here we also have 1, 2, 3, these 3 turning points. If we have 3 turning points, that means that we actually have a degree 4 polynomial. Okay, so if I have a 4th degree polynomial, I should have 4 zeros. And since I only see 3, wow, I spelled that wrong. Oh no. Okay, try this again. I should have 4 zeros, and since I only see 3, that means that I probably have a multiplicity. And actually, I can see an indicator of a multiplicity right here. Remember, when the graph goes up, it touches the x-axis, but doesn't actually go through it and then shoots back down. This means that we have a multiplicity. So my x's are 3, 1, and negative 2. But since we have the multiplicity here, we actually have 2 x's, or 2 factors of negative 2. Meaning that when I write my binomial, it's going to be x plus 2 We always do opposite, right? This is a -2, meaning when I change this over, make it a binomial, it's going to be x plus 2, and it has a multiplicity of 2. For my second one, it's going to be x minus 1. And then finally for my third, x minus 3. So then when I write this out, I'm going to have x plus 2 squared, x minus 1, x minus 3. That is my function. All right, for the next one, we want to know what the relative minimum is within the range -5 to 1. So relative minimum, that means that we are looking for a dip. Remember, minimums look like this. Maximums look like a hill. Okay, so between -5 and 1, so here, 1, 2, 3, 4, 5, here's -5, here's +1. So I'm looking in this area here. My only minimum that I see is at this point. So it is at the point -1, comma, -1, 2, 3. So -1, 3 is my relative minimum. Okay, for the next problem, I'm solving by factoring. So anytime we see this x to the fourth, as long as we have an x squared and then we do not have any x's at all in this third term, we can factor this the same way that we factor a quadratic. Instead of taking the x squared, normally we have an x squared here, we split it into x and x. X to the fourth, we will split into x squared and x squared. And then just like before, we're looking for the two numbers that multiply to give us 36, but add to give us a -13. So if I'm looking for two numbers that add to give me a negative, but multiply to give me a positive, I could say -1 and -36, -2 and -18, -4 and -9, and I think we just found our matches here. And those will add to give me -13. So -4 and -9. And it did ask me to actually solve it, so I need to go ahead and solve these. So for this, x squared minus 4, I am going to set that equal to 0. X squared minus 9, I'm going to set that equal to 0. And solving, so I'm adding 4 to both sides. I end up with x squared is equal to 4. And taking the square root, I'm going to end up with x is equal to ±2. For the second one, adding 9 to both sides. And I end up with x squared is equal to 9. Taking the square root again, x is equal to ±3. So my answers are -3, -2, 2, and 3. Okay, this next one, all I'm doing is classifying. Before we can classify, we have to put it in standard form, meaning that we need to line it up with our exponents in descending order. And here, it looks like we have like terms. So I will start by combining the like terms. So 7x squared. My next term is going to be the 9x, so minus 9x. And then finally, my -3. So now I'm ready to classify it. I classify it first by looking at the degree. It's a degree of 2, meaning it is a quadratic. And it looks like there are 3 terms, and 3 terms, we call that a trinomial. Okay, next I'm looking for the real or imaginary solutions for y equals 64 x to the third minus 1. So this is where we're taking our equation, our friends here, on a roller coaster ride. Right? This is where we're going to end up with a binomial and a trinomial. So you can either memorize the formula for this, or you can think of the roller coaster ride. So first, I'm going to rewrite 64x to the third. That is the same thing as 4x times 4x times 4x. The cube root of 64x to the third is 4x, so I just write it 3 times. That's the same thing as this number multiplied by itself 3 times. Just like 1 is the same thing as 1 times 1 times 1. So we do the cube root of each of these. So next we're ready to go ahead and start. We're going to take our first term. That's going to be the first term of the binomial. So we've used one of our x's. Next, we take one of the ones over here. That's going to be the second term. So we've used one of our ones. Next, we are going to take the remaining 4 x's. We're going to multiply them and put them as our first term in our trinomial. So 4x times 4x is 16x squared. And then finally, the remaining ones, multiplying those and putting them as our third term of our trinomial. To figure out what goes in the middle, this is where our roller coaster ride comes in. We're going to take our first term, our second term, do a little loop-de-loop, and that's what's going to go in the middle of our trinomial. So 4x times 1 gives me 4x. Okay, and the last thing that I need to do here, if you guys remember from the video, scream or puke. That means that I do same, opposite, and plus. So I keep the same operation that I used in my original problem. So I used a minus sign, so I'm going to have a minus sign. And then here is going to be the opposite of the operation I used. So I used a minus, which means this is going to be a plus. And then finally the third one is just always plus. So rewriting this, we can actually see it a little bit better. 4x minus 1, 16x squared plus 4x plus 1. Okay, for our next problem, what is the standard form of the polynomial function? So I'm taking this function, putting it in standard form, meaning I need to start with zeros. I need to figure out what the zeros are. So it looks like I have 1, 2, 3 zeros. All right, so I have an x is equal to negative 3, x is equal to negative 1, and x is equal to 2. So I need to write these as binomials. So the binomial for x equals negative 3 is going to be x plus 3. If we need to, just add 3 to both sides. That's how we get the x plus 3. For the second one, adding 1 to both sides would give us x plus 1. And then for the final one, it's a positive 2, so I'm subtracting 2 from both sides to get x minus 2. Now this is not in standard form. The question asked us for standard form, not factored form, meaning I'm going to have to multiply these. So I will start by foiling my first 2. So x times x, x squared, x times 1, 3 times x, and 3 times 1. Okay, and I'm just bringing this x minus 2 down. I need to combine like terms here. So x squared plus 4x plus 1, x minus 2. And now finally I'm going to have to distribute each term from my trinomial to my binomial. So x squared times x. This is x to the third. X squared times a minus 2. 4x times x. It's 4x squared. 4x times a minus 2. And then finally 1 times x. And 1 times a minus 2. So my last step then is to combine like terms finally, and looks like I have a couple of like terms here. So I have x to the third. When I combine my like terms, I get 2x squared minus 7x minus 2. And that is going to be my final answer. That's my function. Okay, for the next one, I'm writing the polynomial in factored form. So we need to start by factoring out any common factors. I want my greatest common factor. And it looks like the greatest common factor for these three, the only thing they really have in common is an x. It looks like I can only take one x out. So in parentheses, I write what's left over. So x to the third divided by x. If I take an x out of that, I have x squared. 9x squared, if I take an x out of that, I have 9x. And then finally 8x, if I take out an x, I just have an 8. So now I need to write this in, or factor it. So x squared plus 9x plus 8 can be factored into two binomials. I need to look for the two numbers that add to give me 9, multiply to give me 8. So the only factors of 8 are 1 and 8 and 2 and 4. So the two to add give me 9 are going to be 1 and 8. So this is x plus 1, x plus 8. The question only asked me to write it in factored form. It didn't actually ask me to solve it, so I'm done. This is the polynomial in factored form. Okay, and that is going to wrap up our review video. So hopefully you guys study tonight. Try really hard on your test tomorrow. Good luck. And that's all. The end.